If you want to turn your mic on, let me know. Are there any from section 5.6? If you've started to look at this one, are there any that you had questions on that you would like to go over that I can help you with? If you want to throw those in the chat, or if you have your microphone, you can turn on and let me know. 14, thanks, Grace. So we'll take a look at 14. So the idea of section 6, as we start to look at triangles, is the length of a triangle's side starts to compare to its opposite angle. And how it works is the longest side is going to be opposite the largest angle. So in every triangle, the longest side will be opposite the largest angle. So just really quick before I head down to 14, since 5.8 is the longest side, this angle right here is going to be the largest. And all I could do is just kind of put a large there. 4.3, since that's the medium side, that means that this angle opposite is the middle angle. And then 2.7 is the shortest side, so that means that that angle right there is going to be the smallest. So that's a little background on what section 5.6 and how we're comparing triangles. So the longest side is going to be opposite the largest angle. The medium side will be opposite the middle angle, and then the smallest side will be opposite the smallest angle. So as we're comparing in number 14 here, we're kind of keeping that idea in the background. So heading down to number 14, says determine which segment is the shortest in each diagram. So which of these segments would be the shortest? All right. So taking a look at number 14, I'm missing some angles, what I'm noticing first of all. But when I'm determining the shortest side, what I'm going to be looking for is I'm going to be trying to find out where is that smallest angle. Now, a couple of things before we get started. We got to fill in a couple of angles. Anytime in a triangle, if you know two angles, you also know the third angle. So here I've got 114, and then I've also got a 30. Okay, so I've got 114 and I've got a 30. So that means that these two add up to 144, these two together. So then that leaves me with 36 degrees for this angle right here. So that angle is going to be 36. And then over here I've got 110 and I've got 32. That adds up to 142. Okay, so that's going to be 142, which is going to leave me with, let's see, 142. That's going to be a 38 degrees right there. Okay, so there we've got our pieces that we're looking at. Okay, so looking at our triangles, so we've got this angle right here, 30 degrees, is going to produce this side. So if I look at triangle ADB, this one I highlighted in red for sure is the shortest side. But now let's look at the other triangle, CBD. That same side is opposite of the 38. Now the 38 is not the smallest angle that I see in that triangle. So in that green triangle, the 38 degrees is opposite that red side that I highlighted, which is the smallest of the ABD, but it's not the smallest of the green triangle. Now the green triangle I look at, what's the smallest angle I have? It's right here. It's this 32, which is going to make this purple side is going to be the shortest side. So that was going to be CD. So looking at my two triangles, I've got a 30 degrees that was telling me DB is the smallest of ABD, but it's not opposite the smallest angle on the other triangle, so it can't be the smallest of that triangle, so then it's got to be that purple side, CD. So you're finding out where are the smallest angles, and that's going to start to tell us which sides are going to be the shortest. So number 14 is going to be CD. All right, any others from section 14? Oh, section 14, number 14, section 5.6. All right, then we'll start to introduce section 5.7. Leighton said number 3 on section 5.6. Let's take a look at that. Yeah, so number 3, Leighton, you're going to want to draw a picture of this one. So right here, I would draw a picture. And let's call it ABC. Now this is not going to be to scale. I'm just kind of drawing a picture. AB is 8. CA is going to be 7, and then BC is going to be 5. So which angle is going to be the smallest? The angle smallest is going to be the one opposite to 5, so angle A. And then B is going to be the next smallest because it's opposite to 7. And then the largest is going to be C because it's opposite the 8. So then that would be my angles smallest, largest. Angle A, then B, then C. So if we're just given measurements, it'd be a good idea to quickly just draw a picture there. All right, heading on to section 5.7. Section 5.7 starts to look at when you have two triangles. So two triangles, and then how that angle starts to determine the third side of the triangle. So section 5.7 uses the inequality of two triangles, which is also called the Hinge Theorem. What the Hinge Theorem says is if you have two triangles that are in the SAS form, and what I mean by that is you know a side, and then you know an angle in between them, and then you also know another side is congruent. That angle in the middle is going to determine your third side. So here I've got a diagram, AB and AD. I've got a side that's marked congruent, side that's marked congruent. I've got this angle in between. And then I've got this reflexive side over here, side, side. So I've got side, angle, side. Now what the Hinge theorem says is that this angle in each of these two triangles, this angle determines which side is going to be the bigger side. So looking at the two sides I'm comparing, AB and AD, I'm going to be able to start to tell which side is bigger based on that angle. So 41 degrees is bigger, which means that this AD is going to be bigger. 38 degrees is smaller, which means that this AB is going to be the smaller side. So how to write an inequality? I'm going to say that AB is less than AD, or if you wanted to, you could say AD is greater than AB. So if both triangles are in that SAS where that angle in between is different, that angle starts to determine that third side. So you can tell which side is going to be bigger based on that angle. It's called the Hinge theorem because it kind of works like a door. So a door and its frame are going to be congruent. And then as you open that door at a bigger angle, it's going to cause that third side of the triangle, which would be the measure of the door to the frame, the outside of the door to the frame. It's going to cause that side to get larger. So as you open it up, it gets bigger. And as you close it, shorten that angle, it's going to get smaller. So that Hinge theorem starts to determine that third side of our triangle. So looking, continuing, you have a couple other additional problems here. So you can see you have LM and KL. This is also SAS. So you got SAS. So looking here, I've got 82. That's going to mean that this side over here is 9, or this angle here is 98. So this one is going to be larger. And then this one is going to be smaller. So I can tell that by that angle, 98 degrees is larger, which is going to make that KL larger. LM is going to be smaller because 82 degrees is a smaller angle. So that's the basics of what that Hinge theorem is looking at. We are at 8:30, so I am going to stick around and keep taking questions on 5.6 and 5.7. If you want to break off to work on your own, you can. Have a great day. It's good to see you all. I will be here until 8:55 for questions, but I'll stick on the line. If there's any other questions from section 7, I will continue to work on them. If you have questions on section 6,